Now let's talk about rotation. So rotation. So this is turn. So we are going to turn the object. So first we have this. If you want to turn this, now it would not be able to, it will not be easy to be doing this by counting or like we did in reflection. Here we will need construction like a compass and protractor. So if you want to do this physically, first of all you have to decide on the center, because you need a point from where you can turn something. You cannot turn something from nowhere. You need a point. So generally speaking, we turn something from here, which we call the origin. So we take the uh, center as here. We join individual points. So suppose I take this and I join this right through the origin. Then we put the protractor here. If it's a 90-degree anti-clockwise rotation, we put the protractor here and we measure it at the protractor, and then if it is 90-degree through the protractor, we join this, and this would be the 90-degree line. That's what we do. And then individual points we join and we put the point on the protractor, on the line here that we measured with the protractor. And then it is important that the length is equal. So from here to here this is 2 boxes, from here to here it has to also to be 2 boxes. So that's how it is done. It's rather complicated when we use the construction tools, but we're going to do it in the simplest way. We're going to use matrices here. So if we do matrices, let's first write down the matrix of this triangle. So this is 1 2 1 2, then it is 1 4 1 4, and this is 2 3. So this is 2 3. Now we need a matrix for this. So the matrix for this is, if we want to reflect 90-degree, first let's start with 90-degree in the clockwise direction. So there are two types of reflections, 90-degree and then we have 180-degree. 90-degree can be broken down into 90-degree clockwise and 90-degree anti-clockwise. Okay, so when we do 90-degree clockwise, so remember, so this is the origin and we want to rotate this point AB in the clockwise towards the right direction, exactly 90-degree. So this would be flipped. Remember, in rotation every point is exchanged. A goes to the position here and B goes, so the position of the coordinates is exchanged. So this is 90-degree. So here if we again rotate from the origin, so if the point is here, so if the anti-clockwise position would be towards the left, again the values of the coordinates would be exchanged. In case of 180-degree rotation, starting from the origin again, so this time it doesn't matter whether we go in this way or in this way, clockwise or anti-clockwise, we would end up in the same position here. And remember, like before, the coordinates would be exchanged. But remember the quadrant. Here x coordinate is positive, y coordinate is negative. Here x coordinate is negative, y coordinate is positive. So remember the quadrant, and remember we always start with the arbitrary position AB. This is how we think about this. And here in the third quadrant, x is negative and both x and y are negative. So this is how it is. So remember how we write the transformation matrix. It would be the first row is the x coordinate, so xa, xb. The second row is the y coordinate, ya, yb. So this one, this matrix would be, so the x always the image. Remember, when you put down the transformation matrix, it's always the image. So the x coordinate is going to be positive b. So b means here, so it would be 0, 1. And the y coordinate is negative a, so it would be y coordinate is around here, so this would be -1, 0. So let's do this. So let me multiply this with 0, 1, -1, 0. So if I multiply this, I'm going to get 0. The first row is going to be 0. If I'm going to add it with 1 into 2, so this would be 0 plus 2. which is 2, 0 plus 4, which is 4, 0 plus 3, which is 3. Then I'm going to multiply this with minus 1 into 1 is minus 1, and 0 into 2 is 0. So minus 1 plus 0 is minus 1. Then we have minus 1 again. Then we have minus 2 again. I could multiply, or I could just remember this. If I remember this, the AB would be positive, it would be flipped, it would be exchanged, and the first coordinate would be positive, the second coordinate would be negative. So that's what I did here. So I wrote 2, 4, 3, 2, 4, 3, and the second coordinate is all negative. So let me put this down. So 2 minus 1. So 2 minus 1 is going to be here. Let me call this A prime. 4 minus 1 would be here. So let me call this B prime, and 3 minus 2 would be here. C prime. So it's not obvious when you, unless you draw it, it is not pretty obvious unless you draw it. So this is the image of this triangle when it is rotated by 90 degree in the clockwise direction. So similarly, we can calculate what happens when you rotate it in the anti-clockwise direction. So here we can write this. So if the image has x coordinate minus b, so it would be 0, minus 1, and the y coordinate is plus a, so it would be 1, 0, because the position of here ya is taking, so we don't need this, we write a 0 here. So similarly, we can find the image here. So this is the first example. The second example would be 0, minus 1, 1, 0 is the transformation matrix. And the object, since this is the object we're starting with, is 1, 2, 1, 4, 2, 3. So this is going to be, instead of multiplying, I'm going to use this technique over here. So it's going to be reverse. So 2, 4, 3 would be above, and 1, 1, 2 would be below. And the first coordinates would be negative. So this would be negative, this would be negative, this would be negative. It's a trick that you can remember, or you can multiply with the matrices. So this is going to be minus 2, 1. So minus 2, 1 is this. So this is A prime. Then we have minus 4, 1. Minus 4, 1 is this. This is B prime. Then we have minus 4, minus 3, 2. So minus 3, 2 is this. So this is C prime. So if you join it, you'll get the new triangle. So this is what it looks like when you take the origin, you join it, and you rotate it by 90 degree in the anti-clockwise direction. This could also have been done by construction, which would be rather difficult with compass and straight edge. So the next one is 180 degree. Now I would like to mention one thing here. 180 degree rotation is the same as reflection over here. Is the same as reflection on the line y equals to minus x. So 180 degree rotation is the same as reflection on the line y equals to minus x. So in both the cases, we have the point AB becoming minus b minus a. So this would be the case. It would be 0, minus 1, minus 1, 0. So that would be the rotation of 180 degree. So if we do the sum over here, so 0, minus 1, minus 1, 0, which can either be called rotation of 180 degree or reflection on the line y equals to minus x. So the object is 1, 2, 1, 4, 2, 3, and we get, if I just exchange this, it would be 2, 1, 4, 1, 3, 2, and this time both of them would be negative. So negative, 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 negative. So let me put this in the graph. So minus 2, minus 1 is going to be this point. This is our A prime. Then minus 4, minus 1 is going to be this point, which is our B prime. And minus 3, minus 2 is going to be this point, which is C prime. So when you take this triangle ABC and you rotate it in 180 degree, this is the image that you get. So one thing must be mentioned here, that the description is now going to be Let me write the description here. Describe fully the transformation. It would be the object is rotated at uh, the origin, because that is the most rotation, and when you have to describe it, it would always be the origin most of the case. So the object is rotated at the origin by the degree you mentioned, 90-degree clockwise or 90-degree anti-clockwise or 180-degree. So you mentioned by the angle to give the image. Okay, so enlargement is resize, just like you change the size of a shape in a software. So resize. So enlargement is resize, and enlargement is different from the others because this time the transformation matrix is not just zeros and one. It has to be a different number because it is being enlarged. So the transformation matrix, of course it would be a 2 by 2 transformation matrix, but this time it would be a number and another number. Now if the number is more than 1, that means it is being enlarged by becoming larger than the original object. If n is smaller than 1, meaning fraction like half, it is going to become smaller than the original object. If n is 1, that means there's no enlargement. Of course, n couldn't be 1, so that means there's no enlargement, the picture would be the same. Now, one important factor of enlargement is the center of enlargement. The center of enlargement is like if you have a balloon, you have to resize the balloon, or to enlarge the balloon, you have to blow the balloon from a point. So this is, so this is the balloon. So if you have to blow the balloon from here, so then this is known as the center of enlargement. So when you are enlarging from a single point, so suppose this was the original object and you're enlarging from this, like blowing the balloon from this, and the enlarged image is on the same side, the value of n would be positive. On the other hand, if you have a special sort of balloon, like so you have, suppose you have two balloons joined together, you have a special sort of balloon, and when you know blow through here, simultaneously both the balloons suppose enlarges. So this is a different type of enlargement. So it means if the object is over here and the center is over here and the enlarged object is on the other side of the center of enlargement. So it's like this. This is, you join this, you get the center of enlargement. Here, the center of enlargement is on the same side here. So when you join this, you get the center of enlargement. But here, the center of enlargement is in the middle of the two and the object and the image is on either side. When this happens, the value of n would be negative. When this happens, that the center and the object is on the same, center is on one side and the object and image is on the same side, here the value of n would be positive. So the value of n being positive or negative does not mean whether the object is being enlarged or not. That depends on value of n, whether n is more than 2, or that means double, twice means n equals to 2 means double, or less than, maybe if it is half, that means it is halved. But the negative or positive sign is an indication that the object and the image is on either side of the enlargement. So that's how it is. So let me just take the most common enlargement is twice. So let me do an enlargement of 2002. So what happens? Let me see whether it fits here or not. So the point that we have is 1, 2, then we have 1, 4, then we have 2, 3. So let me multiply this. It would just be doubled. Everything would be doubled. So those 1, 1, 2 would become 2, 2, 4. and this would become 4, 8, 6. 2 is a 4, 4 is a 8, 2 3 is a 6. So this is not in the graph. Let me put it anyway. So what is happening here right now is we are going to get this point 2, 4. So 2, 4 is this point. So let me call this A prime, then 2, 8. So 2, 8 is not here. So 6, 7, 8 will be right down here. So this is B prime, and 4, 6. 4, 6 is right around here. Call this C prime. So 4, 6 is C prime. So if I join this, so if I join this enlarged object image, so this is it. This is the image. Now, how do you find the center of enlargement? So the center of enlargement, if we join this, we can see if I join B prime with B and extend it somewhere around here. If I join A with A and extend it somewhere around here. If I join C with C prime with C, if I extend it somewhere around, of course I don't have a scale to know exactly where it is. So the center of enlargement is around here. So they're being blowed, or they're being enlarged from this point. So that's why it is positive. So oftentimes they ask to write down the center of enlargement. So it's a good idea to always check for the center of enlargement by joining the corresponding points. So that's what it means. So enlargement has one more concept that was not present in the previous transformation, and that is ratio of area. Since the enlarged image is of different size, the ratio of the area is important. So the ratio is done like this. So ratio of triangle, suppose object, this time object is triangle ABC, is to ratio of triangle the image, which is A prime, B prime, C prime. It would always be, the object would be considered to be 1, and the image would be considered to be the determinant of the transformation matrix. Let me call the transformation matrix M. Now since the determinant is AD minus BC, if you remember, this is A, this is D, so we multiply this minus multiply this, it would be 1 is to n squared. So that means in case of when you have a ratio, it would always be 1 into n squared in terms of enlargement. So let me write down the description of enlargement. So the description of enlargement would be the object is enlarged. It's a good idea to mention the center if you can just use a ruler and measure it. So it's a good idea. Even if you don't mention the center, that's also fine, but it's a good idea. So the object is enlarged from center, mention the center, with scale factor. Scale factor is how large it is, or just take the value of this matrix n00n. So n is the scale factor. With scale factor, mention the scale factor to give the image. That's it. Now suppose you have the object and the image, but you don't have the matrix. They're telling you to write down the matrix. So you can just calculate the scale factor by just taking any side. Take any corresponding side and find the ratio of image side by object side. So if I count this, this would be, the image side is from A prime to B prime. So 1, 2, 3, 4. And the object size is 1, 2. So 4 by 2 is 2. So n equals to 2. So that's it. So by that we can calculate this n. So n equals to image side divided by object side. Now had the enlargement matrix been minus 2, 0, 0, minus 2, then the object would be around here. So instead of this would be minus 2, minus 4, then it would be minus 2, minus 8 around here, then it would be minus 4, minus 6, suppose here, and the object would be here. So now you can see that the center now would be somewhere around here between them. So the center would be here. So they would be on the either side. That's why it would be negative. So that's the difference between positive scale factor and negative scale factor.